Hi everyone, in this video we're going to look at an introduction to theoretical probability covering sample space, outcomes, and events. So I'm going to start with outcomes. An outcome is a single possible result from a defined experiment. We're talking about probabilistic experiments here. So an example experiment would be to flip a coin 3 times and observe the results. One possible outcome we could see from this is we get a heads, and then a tails. And I'm abbreviating this HHT. Another possible outcome would be heads, tails, and heads. So these are possible results that we could see after just one iteration of this experiment. An important note here is that you want to define your experiment first, and that each time the experiment is carried out, we're usually talking about experiments that can be repeated many times, we get exactly one outcome. So if you're flipping a coin 3 times, heads isn't going to be an outcome from that experiment. That you could have multiple heads happening in any given experiment, but one outcome should result every time you perform the experiment. Now the sample space is the set of all possible outcomes from a random experiment. So in the previous example, if I'm flipping a coin 3 times, there are 8 possible outcomes if we list them all out, and that would be the sample space. So the sample space is this list of 8 possible results. Here I've abbreviated them HHH, HHT, HTH, THH, HTT, THT, TTH, and TTT. So these are all the possible combinations of heads and tails from 3 different flips. Our third term here is an event. An event is a possible result of an experiment, but it differs from an outcome in that events can consist of more than one outcome, or just one. So again, with our flipping a coin 3 times, some possible events might be getting 2 heads or getting 3 heads. If I list these out, there's actually 3 possible outcomes that are included in the getting 2 heads event. So this event is made up of 3 possible ways that could happen. Heads, heads, tails, heads, tails, heads, tails, heads, heads. These are distinct outcomes, but they group together all as one event of getting 2 heads. In contrast, getting 3 heads on this experiment can actually only happen one way. So that's an event that is also an outcome. So the distinction here is that outcomes can only happen one way, and events can happen potentially multiple ways or consist of multiple outcomes. Why does this distinction matter? In many cases, the outcomes of an experiment, so the individual outcomes within our sample space, are equally likely. That's not always the case, but in many of the theoretical probabilities we're looking at, that is a key distinction, that they're equally likely. So the event heads, heads, tails, and the event tails, heads, heads, they have the same probability, and that allows us to easily calculate the probability of any outcome. Events are not necessarily equally likely. So coming back to the example that we were looking at, if I look at the probability of heads, tails, heads, this is one possible outcome from a possible list of 8 outcomes in the sample space. Because all of those 8 outcomes are equally likely, that means that the probability of heads, tails, heads is 1/8. And I'm using some probability notation here that you'll see later in the section. In comparison, the probability of the outcome heads, heads, tails is also 1 out of 8. Any of the particular outcomes listed in the sample space for this experiment would be the same probability, all 1 out of 8 possibilities. The events that we talked about, getting 2 heads or 3 heads, are not equally likely. Because there were 3 different ways to get 2 heads, the probability of that outcome is 3/8. And since there was only one way to get 3 heads, the probability of that outcome would be 1/8. So we often need to break down our events into their constituent outcomes in order to find their probabilities. Here's another example that doesn't involve coins. So you have a collection of fruit in a picnic basket, and you're going to reach in to grab a fruit to give your friend at random. The basket has 5 apples, 3 oranges, and 2 bananas. So since we're reaching in at random, we have an equal chance of grabbing any of these fruits, and that's what makes this a random experiment. The sample space here would be essentially just a list of all the possible fruits that we could grab. But it's important to note that the sample space isn't just apple, orange, and banana. Those are possible results, but they're not outcomes because there are multiple different apples we could choose and multiple different oranges and different bananas. So even though we might not care about the difference between one apple and another apple, there's still 5 possible apple events here. So the number of each type is important when it comes to probability. In this case, getting an apple would be more likely than getting a banana because there's more apples than there are bananas. So here's an example event. I might want to know about the event that you give your friend an apple. This is 5 possible outcomes because even though we might not care about which apple we get, there are 5 different ways to get an apple when you're drawing in from this sample space. In terms of probabilities, this means that the probability of an apple is 5 out of the total number of things in the sample space, or 5 out of 10. This could be reduced to 1/2. So you have a 1/2 chance, 1/2 probability, or a 50% chance of getting an apple. Here's another event. Event B is you give your friend a banana. This is 2 possible outcomes. So it's a single event with 2 possible outcomes. Those would be getting one of these 2 bananas. So again, we might not care which banana it is, but we have 2 different ways to get a banana. So this means that the probability of getting a banana is 2 out of 10, listing the number of possible equally likely outcomes that give us a banana out of the total number from the sample space. Or we could reduce this to 1/5. Final example, my event might look like you give your friend a fruit that isn't an orange. So if I omit all the different orange options, there are 7 remaining fruits. So the probability of getting a fruit that isn't an orange is 7 out of 10. That's it for this video. Thanks for watching.